Okay, yesterday there was a crash in my system, but fortunately I could retrieve the recording, so the recording is on the web. I think there is a bug on the Linux implementation of Zoom client. So in case of crash, it is impossible. My Zoom is not able to retrieve the first part of the recording. So I transferred it to Windows and I succeeded. So for next time, I will know how to do that. Well, as I told you yesterday, today is just for class exercise, since I want that you start working on the next assignment. All the elements of the next assignment are in your availability, since the components are signals, pipes, and above all sockets. You didn't write exercises directly using sockets so far, but I think you can do directly with this assignment. So what we will do today, I will show you two problems and asking you to work all together. You're not so many, so you can work in a whole separate room, but all together without dividing you into small groups. So it is possible also that you meet directly the student with whom you are working now, and the two problems are strongly related to the assignment. So I will not show you exactly, will define with this the next assignment, but I will would give you two problems which are the components of the next assignment. So serially, I will give you exactly those problems. So I start with the first one, sharing the screen and building the description of the problem directly. And the thing I'm asking you to do is to design the solution. Design the solution means doing what we have done yesterday in real time. So remember, I retrieved the first exercise of this kind. I don't know. It was the monitor for the checking the staying alive of the processes, and the technique. It's an informal technique. Is just to design the components to choose the system calls that can allow you to solve the problem, and sketch templates of the programs that will be part of the processes to solve. Okay, so informally, just to design in a rough way, which all the components for the solution and the important points in the processes. Yesterday, we have seen that the idea was to use the system call. I choose the times, but some other system calls could be used to report from the point by the processes, which is the computing time they are carrying out. And another principle was to choose the signal, and so sending a signal just to interrupt the processes so that they could, using a proper signal handler, to answer and report the status of the process, and using the select, using two pipes for connecting the two processes so that they could give you back the status information, timing information, and select just to, with the timeout, to decide if the process is running or not. So these were the components. I just wrote in a sketch on a sheet of paper. The sheet of paper is, you have seen in real time, and is now uploaded in our web. I'm asking you to do the same for the two problems at hand now, and I will describe the first one. Okay, can you see the problem number one? It's a blank sheet of paper, but okay. Can you see the
Yes, we can see it.
screen? Okay. Well, the problem number one is just the second exercise I've given to you 2 weeks ago, but with a slight simplification, and is a scheduling problem. The idea is that you have two processes, just two, the number is not relevant, maybe 3 or 4, and in general, at least two processes, two cycle processes. We don't know what they do, so they're fake processes just to implement the algorithm. Well, I can, what is the code of P1 and P2? It's just an infinite loop. Well, not an infinite loop, sorry, a definite loop. I write here loop for a certain number of seconds for t and seconds. So they're not endless loops. Okay, sorry, I change on the fly. I change on the fly. Okay. Endless loop, loop forever. Loop forever, and they simulate some activity. So you can put a couple of sleep before and after. Before and after what? A message that says that P is doing something. So write the time, for example, the actual time. The actual time means the time of the day. So the actual time, the real time of the system, using the proper system call, and just another sleep. That's a loop. So as soon as Pn starts, it loops forever, and after, for example, 1 second, maybe 2 seconds, 3 seconds, doesn't matter, writes I am P2 and I'm computing, just to make you know that they are working. But you have also a scheduler. Like it was in the second exercise, but slightly changed. The scheduler, I will tell you exactly what is it for. And another process to communicate with the scheduler is not necessary. The scheduler can communicate by itself. So there is a person here, happy, sends and receives commands. Commands are of simply of one kind: start, let me write in blue. Start Pn for 4k seconds means I want that P1 or P2 runs for k seconds and then stops. And that's all. The only command you issue is this one, and you receive back an information that is or Pn started and Pn ended. Here inside there is some communication. You have to design the communication. And important thing, the specification is that you have to implement a time scheduling, flat scheduling. I mean, no priority, nothing, but scheduling. With the time slicing, or that obviously the time slice for every process must be much shorter than the sleeping time inside Pn, and the execution time. The sleep is this one, and the execution time is the one. So that Pn executes for 10 seconds, so the time slice for the execution of P1 should be much less than 10 seconds. So the idea is that during execution, P is interrupted several times by the scheduler so that they proceed computing in time slots. Okay, that's the simplest scheduler as possible. So much simpler than the Unix basic scheduler that we have learned at the beginning of the course, and the one that was specified in the first time I gave you this exercise, in which you remember that the scheduler is a round-robin scheduler with priority, so that the time slice so anytime the scheduler or the switcher, how it's called theoretically inside the kernel, just picks up the first one in the queue that is ready to run, basing on the priority. So their priority is equal simply as soon as P1 runs, every delta t is interrupted, and execution is given to P2. And after delta t, P2 is interrupted, execution is given back to P1. So you choose the time slice. Is not important in designing the system. So the time quantum, I mean, the idea is that, of course, is a relaxed and slow example in which the time of every cycle should be several seconds, and the total time of execution of that you have asked is several loops. So each Pn must be interrupted several times by S using a time quantum that is smaller than the times implied here. Okay, that's that's the problem. No priorities. So what is called the pure round robin scheduling algorithm. So in turn, each process is able to run. That is the basics of every possible scheduler, and the basics of all mechanisms that are in an automation system and in a robotic system in which you want to control the execution of several agents or several tasks that must be able to run, to go independently. That's the problem I want you to design, of which I want you to design a solution. And the guidelines are the same that I tried to sketch yesterday. So decide which are the system calls, so the services that the kernel gives it to you to solve this problem. And I suggest that you start from the system calls. You collect the system calls for a single case. After that, you decide which are the communication channels, because there are several questions. So how you communicate, probably here is simple, since you can use standard in, standard out. What you need here, well, maybe several ways of communicating between S and the two processes, and which are the algorithms for doing that. So write pieces of pseudocodes and so on. This is one of the components, of the two components of the second assignment. And in the second part of the class, I will give you the second exercise asking you to solve. So first, let me save and upload.
A question first, if I may.
Yeah, yes. Yes, you can.
When we say that we want Pn to go for n seconds for computation seconds, or overall k seconds from now, since we have to schedule it, it will just have roughly half of the time. We need to have k seconds assigned to it, CPU running time, or we want that k second from now.
From the moment in which you send the message. So start now and run for k seconds. That means how many loops you have to carry out. But I want a confirmation that the process has started. Okay? You hear me? I can't hear your voice. Hello?
Can you hear me?
Now I can.
Can you hear me? This is
yes. Okay. So it's clear. I will upload the file, and so a big breakout room. Well, first I have to let you share the screen. Okay. So you will be all together in a room. Do by yourself, talk each other, work together, do what you want. I'm not in the breakout room, but you can call me with the button, and I will come in your room. So I will not watch what you are doing. Okay, now okay, it's 20 minutes, 20 minutes or 25 minutes. Okay, I will tell you. Okay, so you are back. Well, it's just an experiment, so I hope that you have discussed it and you did succeed in designing or just putting some ideas for the solution of the problem. There is something on the chat. Okay.
Sorry,
You're
I'm wrong.
talking by yourself. Okay.
Yeah.
No. It's a good idea. It's a good idea. I don't want to spy what you're saying, and that's the reason why I asked you to work in a breakout room instead of in the class. So I was not there. If I appear inside the breakout room, even if the whole breakout room, it will be noticed to everybody that I'm. So you were alone. Second, it's the second component. Let's share the screen. Well, the recording is okay. This is the recording. So this was the first problem. Now okay. Problem number 2. I assume that you are seeing the screen. The idea, just a bit more robotics, but you have to jump inside the simulated world. Suppose you have two agent, 2 tasks, just to have an idea, 2 drones, okay? D1 and D2. They fly, and you want to ask to accomplish some task, in particular, to go in a specific place. So you have a socket server. This is a supervisor of the system. And you communicate with this. To be more realistic, you have another process that is in the real world is a graphic interface, so interface. A process that interfaces the user, so the user always happy. well, with a strange user. Okay, communicates with interfaces. Interface so in this case, as two-way communication. The communication is this kind: just go, drone number n, 1 or 2, to a certain place, let's say X, Y, Z, just this. And you want back messages from drones. One message is reached, I'm drone number N, the place X, Y, Z, or error, maybe during the flight something happens, so it's necessary to, suppose that the drone, as it happens in the real world, stops, or sometimes automatically lands, but in this case we suppose the drone stops and simply sends you back that the target is not reached, and you are in a certain place and wait for another command. Just this, just nothing more. So you have two messages that can be this and so you communicate with the socket server using I don't know what, and the socket server communicates with the drones using we don't know what. Oh well, using surely sockets, because each drone has its own computer on board, so they are connected using a network. Maybe internet protocol, so it doesn't matter. So that's all. Or how to simulate, and because the idea is to really implement this, how to simulate the effect, the algorithm drone 1 and drone 2. Simulation may be done in this way. Receive the command, and the loop, well, of course, is a loop in some way, receive, and the simulation of the execution of the command, that is, as inside a random error may happen or not. Random error, it is possible, or a random time send reached, and that's all. That's all, in the sense that is you to simulate this, you need, of course, as usual, some sleeping, just to simulate the time that expires during the mission and so on. But the idea is to have a random generators, and the random Boolean generator, is there an error or not, and a random time passed that simulates the complexity of the mission, and then reach it, and again waits for reception. So this is the problem. It's not, well, it's simple in principle, As ever, you have to decide which kind of communication, which kind of socket, taking into account also the model, so the reliability of the structure, and how the interface is always aware of what happens, so it can report to the user. The interface is very simple, but it has to be in connection with the server. So this is a classical situation in which the socket server must accomplish several tasks. It's up to you now. Questions about this? So I want to open again and give you 25 minutes and to try to design the solution and take into account that this is the second and last part of the conceptual contents of the second assignment. So if you succeeded in designing problem number one, problem number two, should be easy for you to write the codes for the assignment that I didn't define so far, but you will see very soon. And you will see in the Aula Web before the next week. Okay? So please, go. I will upload also in this case the PDF. If you have questions now. Okay. I stop share and I upload the drawing. So I open the room again and go in 25 minutes. Okay, so you're getting back. Well, okay. I hope that you could work in a fruitful way, and I will I will show you the definition of the second assignment before the end of the week. So I will publish and will comment on the video clip for the next Monday. In any case, I remind you that it's possible to contact me anytime by email and using Skype. Skype just for having a very quick way of contact, so we can schedule just a meeting. Those of you who have to finish the first assignment, please do it. You know that you will be penalized, but very of a short percentage of the possible full score. So please go on and deliver the first assignment for those of you who didn't finish, and those of you who need talking about it, please get in touch with me. Okay, I thank you very much. I hope that all this is useful for you. Give me a feedback of any kind, and use also the board for exchanging information, for publishing solutions and so on. I will solicit you to do that. Okay? Thank you very much. Yeah.
if you may. Could we send our sketches that we developed in these few hours on the forum, or are they
Yeah.
pretty much related to the assignment?
I would like you to publish your sketches because they are not solution of the assignment, so it's are really useful for everybody, and that's the aim of this guy. Thank you very much.
Okay, thank you. I'll try to.
Okay, see you next week, and enjoy your time, and bye. Thank you very much.
Thank you.
Goodbye, Professor.
Goodbye.
Goodbye.